Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 29, 2025, just a few days ago. This paper introduces a new method that allows a smaller 3 billion parameter model to match or even beat larger 7 billion parameter models on key benchmarks. The paper is titled, MoCa, Modality-aware Continual Pre-training Makes Better Bidirectional Multimodal Embeddings. And as we'll see, this new pre-training approach shows some really promising scalability. The authors propose a two-stage framework to transform existing vision language models into more powerful bidirectional models. Also, the authors shared their full implementation on GitHub. It's quite comprehensive. You'll find all the scripts for continual pre-training, contrastive learning, and evaluation. They even included a demo script, so you can try embedding your own text and images to see how it works for yourself. On Hugging Face, you'll find the 3 billion and 7 billion parameter models available for download, along with usage examples for multimodal similarity search. Alright, so this diagram really visualizes that two-stage framework. On the left, we have the first stage, Modality-aware continual pre-training. The model is fed text with some words masked out and an image with patches missing. It then has to reconstruct both. This uses two techniques, masked language modeling, which is like a fill-in-the-blanks game for the AI, and masked autoencoding, where it reconstructs the missing image parts. Then, on the right, the model is fine-tuned with contrastive learning, using diverse data like documents, to tell the difference between correct and tricky incorrect answers. Okay, moving to the results. This table shows how the models perform on the VLM V2 benchmark. This benchmark, which stands for Visual Document Retrieval, is really challenging. It includes 7 different tasks across various domains, like multilingual documents and biomedical data. Now, looking at the numbers, the MoCa 3 billion parameter model achieves the best overall average score at 59.8. What's really impressive is that this smaller model outperforms several much larger baseline models, including a 7 billion and even an 11 billion parameter model. This really highlights the effectiveness of that two-stage training approach. Building on that, this next table shifts to the Massive Multimodal Embedding Benchmark, or MMEB. This is a really comprehensive test with 36 tasks, including visual question answering, where the model answers questions about an image, and visual grounding, where it locates objects from a text description. And again, the results are very strong. The MoCa 7 billion model sets a new state-of-the-art with an overall score of 71.5, while the smaller 3 billion version is still highly competitive. This really validates that two-stage training approach across a very broad set of challenges. So to really understand what makes this two-stage approach so effective, the authors performed an ablation study. That's where they systematically remove key components to measure their individual impact. This table shows the results, and in every single case, removing a piece of the process hurts the model's performance. For instance, taking out the entire continual pre-training stage causes a significant drop. But the most dramatic effect is seen when removing the long-form document pairs during fine-tuning. The score on the VLM V2 benchmark just plummets. This really proves that every single component is vital. And this next figure really drives home the importance of that continual pre-training stage. We see two plots, one for the 3 billion and one for the 7 billion parameter model. Both show that as the number of pre-training steps increases, the model's final performance on the Massive Multimodal Embedding benchmark goes up. It's a nearly straight line. More training equals better results. What's most striking is on the left plot. After enough pre-training, the smaller 3 billion model actually outperforms a much larger 7 billion baseline model. This really demonstrates the powerful scaling effect of this approach. So, to wrap up our look at this work, the key takeaway is really the power of this two-stage training. The authors effectively transform standard models that use causal attention, which is like reading a book and only seeing the words that came before, into models that use bidirectional attention, letting them see the full context of both text and images. This approach proves to be incredibly scalable, allowing smaller, more efficiently trained models to outperform much larger ones. It really sets a new direction for building these multimodal embedding models. That's our show for today. Thanks for joining me on the AI Research Roundup.